now let us design a recursive algorithm to find the value of n factorial. Since n factorial is equal to 1 into 2 into 3 into etc. n, the equation can be computed using the logic of recursion. N factorial is equal to n into n minus 1 factorial when n is greater than 0 is equal to 1. N factorial is 1 when n becomes 0, n is equal to 0. This is a recurrence relation. Since 5 factorial is 5 into 4 factorial, then 4 factorial is returned as 4 into 3 factorial, then 5 into 4 into 3 factorial is computed as 3 into 2 factorial, then 2 factorial is computed as 2 into 1 factorial, 1 factorial is computed as 1 into 0 factorial. When the actual parameter n becomes 0, n factorial is 1, so 0 factorial returns a value 1, so that recursion terminates here. We have the expression 5 into 4 into 3 into 2 into 1, that is 1 into 2 into 3 into 4 into 5, right. This is the value of 5 factorial. So using the recursion, we need to call the same function in the right hand side. Here factorial function is there. In the right hand side, right, the same factorial function. Here factorial, here factorial, here factorial function, here factorial function. Initial value of n is say 5 factorial, so actual parameter is 5. The function call takes the function call assigns the value of the formal parameter is 5. Then it invokes a new recursive call with actual parameter 4 here, then new actual parameter with 3, new actual parameter with value 2, new actual parameter with value 1, new actual parameter with value 0. One stage we need to properly define the termination condition. When n becomes 0, we have to terminate the procedure by returning a value 1. So 0 factorial, simply the value 1 is returned here. Recursion is terminated and the entire result is evaluated and is returned to the calling place. This is the logic of a recursion. Now let us design the algorithm to find the value of n factorial using this recurrence relation. This is said to be a recurrence relation. Algorithm fact parameter is n. Commence n greater than or equal to 0 and n is an integer 1. Algorithm returns the value of n factorial. First check a value of n. If n is equal to 0, then return 1. N is equal to 0, if n is equal to 0, then return 1. This acts as the termination condition. This is the termination condition. Else n is not equal to 0, then return n into fact of n minus 1. Fact, right? What happens here? Function name or algorithm name is fact. Same function is defined here, fact. Initially the formal parameter is n. Here write the actual parameter, right? This is updated to n minus 1. So if n is equal to 0, return a value 1, else return n into fact of n minus 1. Then this if ends with, say, end if, opening curly brace, ends with a closing curly brace. This is the end of algorithm fact. This is a recursive algorithm. Recursive algorithm to find the value of n a factorial. Let us verify the correctness of this algorithm by taking n is equal to 6. Trace for n is equal to 6. What is the initial call? Initial call is fact of 6. Initial call fact of 6. This means 6 is the actual parameter. The actual parameter 6 is assigned to the formal parameter n. Clearly n receives 6, that is the formal parameter n receives the value 6. First we need to check if n is equal to 0. If n is equal to 0, then the value to be returned is 1, else return n into fact of n minus 1. Since n is equal to 6, this is not equal to 0, the expression to be evaluated is return 6 into fact of n into fact of n minus 1. Current n is 6, 6 minus 1, 5, 6 into fact of 5. Now what is fact of 5? Fact of 5 is the first recursive call. Fact of 5 is first recursive call. In this recursive call, the actual parameter is 5, so that the formal parameter n receives a value of 5. Now in the first recursive call, the formal parameter n receives 5, n is equal to 5, 5 not equal to 0. So fact of 5, right, what happens? Returns 5 into fact of 4. This is the execution to be made during the call of fact of 5. That means fact of 5 returns 5 into fact of 4. Now to evaluate fact of 4, this is the second recursive call. New actual parameter is 4, so that the formal parameter n receives the value 4. So during the second recursive call, fact of 4, formal parameter n receives 4, n is equal to 4, which is not equal to 0. The value of fact of 4 is computed as 4 into fact of 3, in which fact of 3 results in the third recursive call. Fact of 3, this is the third recursive call. Finding the value of fact of 3 What is the value of n? N is equal to 3, which is not equal to 0. Formal parameter is n is 3, 3 not equal to 0. So fact of 3 is evaluated as return 3 into fact of 3 minus 1 or 2, in which fact of 2 results in the next recursive call, fact of 2. This is the fourth recursive call. To evaluate fact of 2, actual parameter is 2, formal parameter n receives 2, checking if n is equal to 0 or 2 is not equal to 0. So fact of 2 returns 2 into fact of 2 minus 1, 1. Now fact of 1 invokes the recursion. Fact of 1 is the fifth recursive call. Fact of 5, fact of 4, fact of 3, fact of 2, fact of 1. Fact of 1 is the fifth recursive call. To evaluate fact of 1, the formal parameter n receives 1, 1 is not equal to 0. Now fact of 1 is evaluated as return 1 into fact of 1 minus 1, 0. Fact of 0 is the next recursive call. Fact of 0 is the sixth recursive call. To evaluate fact of 0, 0 is the actual parameter. The formal parameter receives n receives a value 0. In the conditional statement we have checked if n is equal to 0, then return the value 1. Now since n is equal to 0, right, this is equal to 0, condition is true. So fact of 0 is evaluated, right, the value is 1, return 1. Fact of 0 simply returns a value 1 to the calling place. Who is the caller here? 1 into fact of 0. When fact of 0 is called, the value to be returned is 1. So here updating the value 1 here, 1 into fact of 0 is 1, 1 into 1, 1. Fact of 1 is updated to a value 1. Who is the caller of fact of 1 here? 2 into fact of 1, return 2 into fact of 1. Fact of 1 is 1, this value is returned here. Since the recursion is evaluated using stack, lost in first out order, 2 into 1, 2. Return 2. Who is the caller of this fact of 2? Here 3 into fact of 2, return 3 into fact of 2. Fact of 2 is 2. So here 3 into 2, 3 into 2, 6. Next, who is the caller of this fact of 3? Here return 4 into fact of 3. 4 into return value is 6. 4 into 6 is 24. Then the caller of fact of 3 is this one, 5 into fact of 4. Fact of 4 is 24. 5 into 24, this is 120. Return 5 into fact of 4, that is 120 is returned here to the computation for fact of 5. Who is the caller of fact of 5 here? The first call, initial call, right, fact of 6 invokes the statement return 6 into fact of 5. Fact of 5 has been computed as 120, 6 into 120. this is evaluated. Factor of 5 is evaluated as 120, that value is returned here. So returning factor of 5 as 120, 6 into 120, 720, 720 is returned to the calling place, right? Who is the caller of this one? 6 into factor of 5, factor of 6 is the caller. So the return value is assigned here, factor of 6. So clearly factor of 6 is equal to 720, this is equal to 1 into 2 into 3 into 4 into 5 into 6. So 6 factorial is computed and the result is returned to the calling place. So clearly, right, in the initial call factor of 6, the algorithm returns a value 720. Since n is not equal to 0, every stage, right, factor of n calls factor of n minus 1, factor of n minus 1 further invokes factor of n minus 2, etc. in the last but one, factor of 1, then the last stage, factor of 0 terminates the recursion by returning a value 1. So that this expression n into factor of n minus 1, this return statement evaluates this expression n into n minus 1 into n minus 2 into etc. 3 into 2 into 1 into, finally if n is equal to 0, then return 1, 1 is returned here. So that 1 into 2 into 3 into etc. n, this is equal to n factorial, and the result is returned to the calling place. This is the logic of a recursion to find the value of factorial of the given positive integer. Let us solve the recurrence relation to verify the recurrence relation works correctly. Let us solve this recurrence relation. Solve the recurrence relation factor of n is equal to n into factor of n minus 1 when n is greater than 0, factor of n is equal to 1 when n is equal to 0. We can solve the recurrence relation using the substitution method. What is the relationship given? Factor of n. Factor of n is equal to n into a factor of n minus 1. Call this as equation 1. Second equation says when n becomes 0, so putting n is equal to 0, factor of 0 is equal to 1, 0 factorial is 1. This is equation number 2. Equation 1, right, this is to be a recurrence relation because the same function name fact is appearing, right, or fact is occurring in both sides of the equation. Here fact, here fact. Here actual parameter is n, here actual parameter is n minus 1. So considering the recurrence relation 1, we need to find the value of the recurrence relation, repeatedly substituting the value until the recursive relationship terminates in the right hand side. so that we will evaluate the value of fact of n. Now starting from the left hand side, or from equation 1 implies fact of n is equal to n into fact of n minus 1. In this equation, first recursive call is made with actual parameters n minus 1, fact of n minus 1. Now to find fact of n minus 1, we need to substitute n is equal to n minus 1 in equation 1. Put n is equal to n minus 1 in equation 1. We can find the value of fact of n minus 1. Now putting n is equal to n minus 1, fact of n minus 1 is equal to n minus 1 into fact of n minus 1 minus 1. So this is n minus 1 into fact of n minus 1 minus 1, that is equal to n minus 2. So writing here, this is n into fact of n minus 1, this value is substituted here, n minus 1 into fact of n minus 2. Now in this equation, fact of n minus 2 is a recursive call. To find the value of fact of n minus 2, substitute n is equal to n minus 2 in equation 1. Putting n is equal to n minus 2 in equation 1, we have fact of n minus 2 is equal to n minus 2 into fact of n minus 2 minus 1, that is n minus 3. Substituting the value of fact of n minus 2, here this value is substituted here. Now the equation becomes n into n minus 1 into n minus 2 into fact of n minus 3. Similarly, we can find the value of fact of n minus 3. Substitute n is equal to n minus 3 in 1. We have n into n minus 1 into n minus 2 into n minus 3 into fact of n minus 3 minus 1. That means fact of n minus 4. Then we can evaluate fact of n minus 4 as n minus 4 into fact of n minus 5. So this goes on. We need to terminate the recursion. How to terminate the recursion? N into n minus 1 into n minus 2 into n minus 3, etc. Fact of 1. Consider here, fact of n minus 1 means previous term is n minus 1 plus 1, that is the previous term is n here. If we put right fact of n minus 2 at the end, the previous term is n minus 2 plus 1 is equal to n minus 1 here. If the last term is n minus 3, fact of n minus 3, n minus 3 plus 1 is equal to n minus 2 here. If the last term, this as fact of n minus 4, in n minus 4, adding 1 into that, we have n minus 4 plus 1 is equal to n minus 3. So initially write fact of n, fact of n minus 1, fact of n minus 2, fact of n minus 3, n minus 4, etc. One stage, the last term becomes fact of 1. clearly the previous term is 1 plus 1 is equal to 2. So here the previous term is 2. If this is 2, right, its preceding term is 3, 2 into 3, next preceding term is 4, right. So etc., right, the last term here from right to left, 2 into 3 into 4 into etc., last term is n from right to left. Now consider, right, what happens when fact of 1 has been called. In fact of 1, right, we have the same recurrence relation, right, equation 1. Putting n is equal to 1 here, putting n is equal to 1 in equation 1, find a value of fact of 1. Fact of 1 is equal to 1 into fact of n minus 1. n minus 1 is 0. Now substitute the value of fact of 1 in the last equation here as what is fact of 1? 1 into fact of 0. n into n minus 1 into n minus 2 into n minus 3 etc., 3 into 2 into fact of 1 is substituted as 1 into fact of 0. Fact of 0 is the next recursive call to be made. Fact of 0 has been set as 1, right. So using equation number 2, now equation 2 is applied. Since from equation 2, fact of 0 is equal to 1. Substituting the value of fact of 0 as 1, we have n into n minus 1, n minus 2, n minus 3 etc., 3, 2, 1, fact of 0 is 1. Now this is equal to 1 into 2 into 3 into etc., n minus 1 into n. This is the value of n factorial. What is the left hand side function call? Fact of n. Fact of n, right, in the left hand side. Fact of n is equal to 1 into 2 into 3 into etc., n minus 1 into n. That means the value of n factorial is obtained. So clearly this recurrence relation defined by equations 1 and 2, fact of n is equal to n into fact of n minus 1 and fact of 0 is equal to 1, output the value of n factorial. So this recurrence relation works correctly to find the value of n factorial when n is greater than or equal to 0. When n is 0, right, simply fact of 0 is equal to 1, right, 0 factorial, the value 1 is returned. This is the recursive logic to find the value of or to find the factorial of the given positive integer. So using the iterative approach or using the recursive approach, we can design the algorithm